Ever pondered over the intricacies of how a DC motor operates? How does this compact device transform electrical energy into mechanical motion? This question may have crossed your mind as you tinkered with your engineering projects or just out of sheer curiosity. A DC motor is a fascinating piece of technology that is a fundamental part of our everyday lives. It powers everything from the electric toothbrush you use every morning to the subway trains that ferry millions of people around the world each day. So, how does it work? Well, today we're going to unravel this mystery for you. At the heart of every DC motor lies the basic principle of electromagnetism. This principle states that when a current-carrying conductor is placed in a magnetic field, it experiences a force. This force, known as the Lorentz force, is the driving force behind the motor's operation. Imagine a rectangular coil of wire. This coil, which we'll call the armature, sits inside a magnetic field created by two permanent magnets. Now, when a direct current from a battery or power supply is passed through the coil, it becomes an electromagnet. As an electromagnet, the coil generates its own magnetic field. This field interacts with the field from the permanent magnets, causing the coil to experience a force. This force pushes one side of the coil upwards and the other side downward, resulting in a rotational motion. But wait, there's a catch. If the coil were to continue spinning like this, it would eventually rotate a full 180 degrees. At this point, the sides that were previously being pushed up and down would now be in the opposite position. This would reverse the direction of the force, causing the coil to abruptly stop and spin back the other way. This is where a clever piece of engineering comes into play: the commutator. The commutator is a split ring that reverses the direction of the current every half turn, keeping the coil spinning in the same direction. So there you have it. The coil or armature continues to rotate, and this rotation is transferred to the motor's shaft. This generates the mechanical motion that powers everything from your electric toothbrush to the world's subway trains. In a nutshell, a DC motor transforms electrical energy into mechanical energy. It does so by using the Lorentz force produced by the interaction of magnetic fields and a current-carrying coil. The coil rotates within a fixed magnetic field, and the commutator ensures it keeps rotating in the same direction, producing continuous mechanical motion. Understanding the principles behind the humble DC motor not only quenches our curiosity, but also gives us a greater appreciation of the engineering marvels that permeate our daily lives. So, the next time you use an electric device, spare a thought for the little motor that makes it all possible.